We continue our lecture 2, the basics of counting, with the division rule. The division rule says that there are n divided by d ways to do a task if it can be done using a procedure that can be carried out in n ways, and for every way, w, exactly d of the n ways to correspond to way w. How many different ways are there to seat 4 people around a circular table where 2 seatings are considered the same when each person has the same left neighbor and the same right neighbor? Solution. We arbitrarily select a seat at the table and label it seat 1. We number the rest of the seats in numerical order, proceeding clockwise around the table. Note that there are 4 ways to select the person for seat 1, 3 ways to select the person for seat 2, 2 ways to select the person for seat 3, and 1 way to select the person for seat 4. There are 4 factorial ways in order to order the given 4 people for these seats. However, each of the 4 choices for seat 1 leads to the same arrangement, as we distinguish 2 arrangements only when one of the people has a different immediate left or immediate right neighbor. Because there are 4 ways to choose the person for seat 1, by the division rule, there are 24 divided by 4 equals 6 different seating arrangements of the 4 people around the circular table. Tree diagrams. Counting problems can be solved using tree diagrams. A tree consists of a root, a number of branches leaving the root, and possible additional branches leaving the endpoints of other branches. To use trees in counting, we use the branch to represent each possible choice. We present the possible outcomes by the leaves, which are the endpoints of the branches, not having other branches starting at them. Example 21. How many bit strings of length 4 do not have 2 consecutive ones? Solution. The tree diagram in figure 2 displays all the bit strings of length 4 without 2 consecutive ones. We see that there are 8 bit strings of length 4 without 2 consecutive ones. So we begin with our first bit, and we can choose it either as a 1 or a 0. If we choose the first bit as a 1, then the second bit must be a 0, so there's only one alternative. If our first bit was a 0, then we can choose the second bit either as a 1 or a 0. On our left-hand side, since the second bit was a 0, we can choose the third bit as either a 1 or a 0. In our next branch, since our previous bit was the 1, then we must choose a 0. And in our final alternative, since our bit was a 0, we can choose either a 1 or a 0 for the third bit. Finally, for our fourth bit, our leftmost choices must be a 0 because our third bit was a 1. In the next case, our third bit was a 0. We can choose either a 1 or a 0. In the next case, we can choose either a 1 or a 0 because our third bit was a 0. In this 1, 2, 3, fourth case, we have a 1 bit, so we must choose a 0. And in the fifth case, we have a 0, and we can choose either a 1 or a 0 bit. So the bit strings altogether that do not have consecutive 1s together are 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, and quadruple 0. Here is a question that's like the ones that you'll have to do. 6 different airlines fly from New York to Denver, and 7 fly from Denver to San Francisco. How many different pairs of airlines can you choose on which to book a trip from New York to San Francisco via Denver when you pick an airline for the flight to Denver and an airline for the continuation flight to San Francisco? Apply the product rule. 6 times 7 is 42.